So the current technique means you use mechanical methods to process concrete, but this has many drawbacks. If you crush concrete and recycle these so-called secondary aggregates in new concrete, you create a kind of a downcycling. This new concrete needs more water, it has lower compressive strength, and to overcome all these drawbacks, you need organic additives. So we try to solve this problem by applying a new method as an alternative to mechanical processing, and this method is called electrodynamic fragmentation. Basically, we are shooting some lightning strikes onto the concrete. The lightning strikes run along the path of the least resistance, which are the grain boundaries in concrete, which means this is the boundary between the aggregates and the cement stone. The cement stone is the binding matrix in a concrete, and these pre-discharges can weaken a composite material like concrete. And one of these pre-discharges will reach the counter electrode, and which leads to the development of a so-called plasma channel. The plasma channel will expand in the concrete, which means the concrete is torn apart. The lightning is generated in a so-called Marx generator. This is a combination of various capacitors which can create high voltages between 70 and even up to 500 kilovolt. The benefits are very clear. We can regain a high quality aggregates. These aggregates are free of cement stone, which means we don't have the problems in the recycling in new concrete. These aggregates will behave like original aggregate. And we obtain this calcite and calcite-rich fraction, which can be used as a raw material for cement or as a grinding additive for the clinker production. So we are working on a lab scale machine. This means with only a 5-liter vessel, but even in this vessel we can process about 1 ton of concrete per hour. We are collaborating with a company who can produce bigger machines and pilot plants. So currently they have a pilot plant which can process about 3 tons of concrete per hour. But we're working on a national funded project with the goal to develop a process which can handle with about 20 tons of waste concrete per hour. We expect that we can build such a machine in about 4 to 5 years.